Hi, we're here at AGU, and I'm going to talk about my poster on the seismic particle motion of air-to-ground coupled waves. So this work comes out of theoretical models that predict the particle motion to be retrograde elliptical during coupling, but we have a lot of these examples of prograde motion. So essentially we've developed a method to quantify the sense of either retrograde or prograde in the time frequency domain. Our method takes advantage of the radial seismic and the vertical seismic component. It looks at the phase between the two. We looked at the 2012 Camp Midden explosion as kind of a case study. You can see here on the map where the blue is these prograde stations in the 1.5 to 10 hertz band, and the red is the retrograde stations. We had about 38% of the sites with coupling from this particular event had prograde motion, so it was a great example of the prevalence of prograde motion. We also saw this relationship with the VS30, which is the base map of this figure, and prograde motion. So you can see this Mississippi embayment has lots of prograde motion at these low shear wave velocities. These figures here kind of show the time frequency representation of particle motion. Here we have broadband retrograde motion, broadband prograde motion, and some frequency-dependent prograde motion. So our thoughts are that the particle motion is kind of a proxy for subsurface structure, and we can learn something about the shallow subsurface by looking at the particle motion of these coupled waves. Some future directions that we're moving in is to understand a little bit more about why we get prograde motion. Some cases show it at really low frequencies, which doesn't really make sense with previous observations, so we're interested in looking at that in the future. This is my first time here at AGU. It's been really great to connect with other researchers and learn about all the cool science that everybody's doing.